Hi, GOR. This is an explanation of the homework from lesson 6. So if we're looking at question number 1, I want to find the measure of angle YZV, and I highlighted that in yellow on the picture for us. That is not a central angle because the vertex is not in the center of the circle, and it's also not an inscribed angle. It's just an angle that's inside the circle. And this is one of the new rules that we learned in this lesson, is that when you have an angle that's not a central angle, it's not an inscribed angle, it's just inside the circle, that angle is going to be equal to 1/2 the sum of the arcs. Which arcs? The arcs that are on either side of that angle. So I highlighted those arcs in green for us. So it's going to be 1/2 the sum of the angle on the arc on the left and the arc on the right. So I'm just going to plug that in, 1/2 of 144 plus 114. And I can put that right into my calculator and I get 129. So anytime we have an angle that's inside a circle, but it's not a central angle, it's not an inscribed angle, the formula that we're going to use is it's 1/2 the sum of the arcs. The same thing is happening right here also on number 2. I'm just going to grab my highlighter as we're doing this. The difference on number 2 is I actually have the angle. So this is the arc, this 161. The other arc is X. I don't know what that angle is, and what that arc is, and I have the angle. The angle is 93. It's not a central angle. It's not an inscribed angle. It's just an angle inside the circle. And the rule is the angle equals 1/2 the sum of the arcs. So I know the angle in this case. So the angle is 93. It equals 1/2 the sum of the arcs. I don't know one of the arcs. So I have X plus 161. The easiest thing to do is to get rid of this 1/2 by multiplying by 2. So I multiply the 93 by 2, and that's where that 186 comes from. So now I have 186 equals X plus 161. To solve, all I have to do is to subtract 161, and that's how I get 25 as my answer. There's actually 2 ways to do question number 3. So question number 3, this angle right here, PQS, is 128 degrees. To me, it looks like it's an inscribed angle. It's technically not an inscribed angle. I highlighted it in blue right there for you. But it looks like an inscribed angle. It has the same exact rule as the inscribed angle. The angle is 1/2 the arc. So if this angle was 128, that's how I know that this arc right here is 256. The question, though, actually is asking me for RQS. RQS I have highlighted in green right here. So these two arcs together form a complete circle. So all I did was 360 minus 256, and that's how I got the 104. Number 4, I want angle EFG. Now this is a different rule. Angle EFG I have highlighted in green. Angle EFG is outside the circle. Anytime I have an angle that's outside the circle, this is the rule I use. The angle is 1/2 the difference of the arcs. Which arcs? The arcs that are between the two sides of the angle. So this arc right here, that's 121, and this arc right here, that's 39. And I always do the bigger arc minus the smaller arc. So 1/2 of 121 minus 39, and that gives me 41. So the 2 rules are, like question 1, if the angle's inside the circle, it's 1/2 the sum of the arcs. If the angle's outside the circle, it's 1/2 the difference of the arcs. 5 is arc CF. So this angle right here, angle DEF, is 53 degrees, the one that I have in green. And that angle is outside the circle, so I'm going to use the rule 1/2 the difference of the arcs. The thing is, I don't know what the arcs are, so I'm trying to find this arc CF right there. So I can call that arc CF. This is my X right here. Okay, so it's going to be the angle, which is 53, equals 1/2 the difference of the arcs. It's always the big arc minus the small arc. To get rid of the 1/2, I multiply by 2. So 2 times 53 is 106. And then to solve for X, I'm going to add 41, and that's how I get 147. Number 6, I want to find angle TUV, and that's the angle in green right there. It's outside the circle, so I'm going to use that rule. The angle is 1/2 the difference of the arcs. The problem on this one is I don't have this arc right here, TSV. I have it written down that it's 252, but how did I get that? I know this arc is 108, And you can see that those two arcs together form a complete circle. So I did 360 minus 108, and that's how I figured out that that big arc is 252. So again, the angle is outside the circle. It's 1/2 the difference of the arcs. The bigger arc, 252, minus that smaller arc, 108, and that's how I get 72. 7 is an angle that's inside the circle, but you can see I have an x right here. I have a binomial, so it's going to just be a little bit more complicated to solve algebraically. But the angle is inside the circle, so the rule is it's 1/2 the sum of the arcs. So the angle is 5x minus 7 equals 1/2 of 119 plus 27. The two arcs, see them on either side. They're highlighted in green, so you can see where I got them. I multiplied by 2 to get rid of the 1/2. So when I multiply 5x minus 7 times 2, I get 10x minus 14. And then I'm just going to combine these. The 119 and the 27 gives me 146. And I add 14, which gives me the 160. And I divide by 10, and I get x equals 16. On number 8, similar problem, but the angle is outside the circle, so I'm going to do 1/2 the difference of the arcs. Remember, it's always the bigger arc minus the smaller arc. So the angle is 2x plus 7 right here on the left equals 1/2 the difference of the arcs, the bigger arc minus the smaller arc. Now I can do the same thing I did on problem 7, and I can multiply by 2. But I wanted to show you can also just take half of this, because this is just a number. It's an even number. It's not like I'm going to get a decimal or anything like that. 78 minus 32 is 46. Half of 46 is 23. I subtract 7 to get 16, and then I divide by 2, and I get x equals 8. Okay, so that was the lesson 6 homework answers.